take another few minutes to check out variables and make sure we understand how variables work. So again, these are the types of variables that you might encounter: the independent variable, the dependent variable, and then the constant variables. And remember, independent variable, it's IV. It's the one I change on purpose, the one I decide ahead of time, I manipulate it. The dependent variable is the data that you take. You're not sure what's going to happen. It depends on the independent variable in the experiment. It responds to the independent variable. The constant variables or controlled variables are the things that stay the same as much as you can do it. It helps the experiment stay fair. And if you can't do it because you're studying humans, then you can just study a lot more humans so that the constant variables can be discounted or show how they can stay out of play. And we want as many of those as we can get. So let's practice. Which ball will roll the fastest down a hill, a tennis ball or a soccer ball? That's our question. We're trying to figure out what is the dependent variable. So the dependent variable is the thing you're going to find out when you actually do the experiment or the study. So we're going to figure out how fast they roll down that hill. That's the dependent variable. The independent variable is the thing that's decided ahead of time. We can decide we're rolling a tennis ball and a soccer ball. So the type of ball is our independent variable. Now, notice both of those things, those categories, were found in the question itself. Rolling the fastest, that was our dependent variable. The type of ball right here, tennis or soccer, that was the independent variable. They're right there in the question. They don't always come in a certain order, but they are there in the question. Now, the constant variables, those ones don't show up in the question because it's all the details, all of the things in the experiment you're doing or the study that you're doing to make sure that your results are fair. So on this one, you would want a lot of things to be the same. You'd want the amount of resistance, like the type of friction on the ground, to be the same. You would want the air resistance to be the same. You would want the spot that you let them go to be the same. You want the ramp to be the same angle. You want everything else to stay constant so that it can be a fair experiment. How about this question? How does the length of a paper airplane affect the amount of time it stays in the air? So the length of the paper airplane, if I was doing this experiment, I would put all the paper airplanes together ahead of time at different lengths, and I would decide them. Maybe I'd do like a short one that's like 2 inches, and then a 4 inches, and then 6 inches, 8 inches, 10 inches, and then I'd fly all the paper airplanes in some way that is as fair as I can get it, and then I'd measure the amount of time it stays in the air. So the dependent variable, the data I'm taking during the experiment, is the amount of time it stays in the air. That's my data, dependent variable. Independent variable was the thing I got to decide, and that was the lengths of the airplanes. I set it up ahead of time. And then the constant variables are everything else. You don't find them in the question, but they're really important. Like, I don't want to use the same type of paper every time, the same kind of room or amount of wind. If possible, I'd want to throw them in the same way, or even better, use some kind of machine that makes sure it's thrown in the same way. I've seen those paper airplane machines. All the things you want to stay the same to keep this experiment fair. Another concept we need to think about is the control group. The control group is what you compare your experimental groups to in order to see if there's an effect. It's generally the zero amount or the normal type or amount of something. There's not always a normal or a zero amount in an experiment, so just keep that in mind. But let's look at examples so you can understand what I'm talking about. So in this experiment, we're asking, does this fertilizer help houseplants grow? And so in one group, we had 20 milliliters of fertilizer, then 30 milliliters of fertilizer in another group, and 40 milliliters of fertilizer in another group. And we're trying to answer that question. Does fertilizer help houseplants grow? Here's the problem. Maybe this fertilizer is actually killing the houseplant, but we don't know because we have no plants without fertilizer. Maybe if you didn't put any fertilizer, it would have been growing way up here. We don't know that. So we need a control group. We need one with no fertilizer. Here's another example if we're trying to see what type of liquid helps the plants grow. One's Coca-Cola, one's juice, one's water. In this case, we don't want a zero amount. We want the one that's normal. So your water group is going to be your control group in that case. On this one, regular soil is your control group. Miracle-Gro is your experimental group.